good day everyone, welcome back again to another tutorial by Smart Build Guides in fluid properties, and in this tutorial we are going to discuss a problem on viscosity again. In this problem we are told that the space between two square flat parallel plates is filled with oil. Therefore we have two square plates that are parallel and the space between them is filled with oil. And each side of the square plate, each side of the plate is 720 millimeters. Since it's square, the length and sides are going to have the same magnitude. And the thickness of the oil film, that's the thickness of the film, the distance between the two plates is 15 millimeters. The upper plate which moves at this upper plate, it moves at a velocity or speed of 3 meters per second, and it requires a force of 120 Newton to maintain the speed. We are told to determine the dynamic viscosity, which is mu, and we are told to determine the kinematic viscosity, which is V, given that the specific gravity of the oil is 0.95. Let's start with the first one, that's the dynamic viscosity. From the Newton's law of viscosity, which says shear stress is equal to viscosity times change in velocity times change in distance, that's the rate of shear stress. We know that shear stress, tau, is equal to force over area. And the area, we are going to take the area of the plates, and the plate is a square. Therefore, the force given is 120 Newton over the area. Area of a square is the length times the breadth, and they have both same length of 0.72. That's 0.72 times 0.72. Calculating, you will see that the shear stress tau is going to be 231.5 Newton per meter square. The thickness of the oil is going to be the change in Y, and we are given that the change in Y is 15 millimeters, or we can say 0.015 meters. Then the velocity U of the upper plate is 3 meters per second. Therefore, the change in velocity is going to be the initial minus final, and we are told that we want the plate to maintain constant speed. Therefore, we don't have any change of speed. 3 minus 0, which is going to be 3 meters per second. This is our du. Now, to determine the viscosity from the Newton's law of viscosity, du by dy, we can say that viscosity is equal to the tau dy by du, which we all have as 231.5 times dy, which is 0.015, divided by the change in velocity, which is 3. Calculating this correctly, you will see that my dynamic viscosity is going to be 1.16 Newton second per meter squared. Then the B part of the question, which told me to find the kinematic viscosity V, is very simple, because I know that kinematic viscosity and dynamic viscosity have a relationship, which says that the dynamic viscosity is equal to the density of that fluid or the oil, since now I'm talking about the oil, times kinematic viscosity. But I don't have the density of the oil, I'm only given the specific gravity of the oil. I know that the specific gravity is the ratio of density of that fluid. For specific gravity of any fluid is equal to the ratio of that fluid with respect to density of water. Therefore, the density of fluid is just going to be the specific gravity of that fluid times the density of water. And for this oil, I'm told that the specific gravity of the oil is 0.95. Therefore, the density of the fluid is going to be 0.95 times the density of water, which is known to be 1000 kilograms per meter cube. Therefore, the density of the oil or the fluid is now 950 kilograms per meter cube. So since dynamic viscosity is equal to density times kinematic viscosity, therefore kinematic viscosity will just be the dynamic viscosity over the density. I have everything here. Now all I have to do is to say that the kinematic viscosity is equal to the dynamic viscosity, which is 1.16, divided by the density, which is 950, and all I have is 0.00122 unit is meter squared per second. This is my kinematic viscosity. I hope you enjoyed this video. If you enjoyed, kindly subscribe to the Smart Build Guides channel and press the bell icon so that you'll be notified when we upload our next video. See you in the next video.